Gray code. Let's talk about gray code a little bit. We have two diagrams here that represent the 4-digit binary codes, black being a 1 and a white being a 0. And here on the left, in case A, we have regular binary code, which is just counting 1, 0, 1, 10, 11, 100, 101, and so forth up to 1111. In gray code, each word differs only by 1 bit from its neighboring code words. And so actually the initial binary code is reordered to make sure that only 1 bit changes between consecutive or neighboring values. Gray code is useful for encoding the position of a linear or rotational actuator. Think of if you have an optical sensor that is shining down 1 for each column, for the thousands, the hundreds, the tens, and the ones. And as this strip here is moving under some optical sensors, so there'll be 4 of them, the optical sensors are detecting when there's white and when there's black. And you can see that, imagine there could be some ambiguity if 2 of those place values change from dark to white or white to dark on the same boundary. And so gray code ensures that only 1 place value changes from a 0 to 1 or 1 to 0. Gray code helps avoid encoding errors due at the boundary of, or between adjacent code words. So here's a little animation to show how it might look. Here we go. There we go. Okay, so these are representing optical sensors. Think of light shining down and bouncing back up, and you've got a sensor that's detecting if it's white or black. So we're in a position 0. Both sensors are detecting 0, 0, 0, 0. Now we move to this position, this 4th position here. And then we're going to show how when you move from the 4th to the 5th position, right now you're going to cross 3 boundaries, or 3 boundaries are going to change, 3 place values, I guess, are going to change across this boundary for the binary code version. The 1s, the 10s, and the 100s, right here, and right here. Whereas over in gray code, only the 100s column is changing. Okay, now how do we make gray code? Here is 1-bit gray code, it's just 0 and 1. 2-bit gray code is 0, 1, and then we reverse the next 2. So instead of 10, 11, we go 11, 10. 3-bit gray code is produced by using the 2-bit gray code and then adding the next column as 1s, then subsequently adding the 2-bit code again but in reverse order, and then adding 1s for the added bit.